Hello everyone, today I'm going to show you how I made my AI for the AIA competition on bots. So the first step I took was to start analyzing the program, see what we have. So as you can see, we have a lot of buttons here, and I'm only going to need to use these two buttons here for now. So what I'm going to do first is load the default AIA lander, and here you can see that we get this AIA lander. This bot is made by AIA and is the default one once you open the program. So what we're gonna do is we're gonna click this button to see this default code. So at first I started to analyze what we have here. So it seems like we have this part here, which is just like a customization for your bot, where you can set the name, the country, the skin, body style, and all other stuff. And here's the main code that controls the player or the bot. See, we have a basic rule here that makes the bot eat when the hunger drops below 50%, and this is passed through a auto position that decides where the player should go based on the state that is set. And here we can see we have an eat state and we have a gather state. These two states are passed into a conditional set state that decides whether to set the state to eat or gather based on what the hunger percentage is. And that's how he controls the player's actions. And here we have a stamina control. These nodes basically make the bot run if the stamina is above 50%. This is decided through this compare floats that gets the stamina percentage and compares it with 0.5, which is 50%. And if it's more than 50%, then the bool becomes true, which gets passed down to this controller, which sets the sprint to true. And here we can see an unused node, which is the emote node. So after analyzing this code, we can see that we have a lot of other nodes here on the side. We can load, save, and clear, and we have a lot of other nodes here. And that's everything for this code that AIA made. So we can click this button to get out, and we can go to the side panel. We can here regenerate the terrain. We can randomize the seed. So the first thing we're going to do is see what the bot does. So as you can see, the bot starts by gathering. We can also open the code and minimize it to see what's happening in real time. So you can see this bool is false, and that's because this compare floats is negative. And now that the hunger drops, you can see that it slightly became true and then became false again, meaning that the player went to eat and came back. You can notice one issue, which is this jittering that happens. This is mostly because of how stamina is controlled, because when the value gets below 0.5, it instantly goes back up because the player stops sprinting, which is another issue because this kind of wastes our stamina. And you can see how the auto position is also working because it's making the player move around. This is the most basic code that lets the bot survive for the entire game. So what I did was I experimented with the AI and started to make different things and experiment with them and let them survive and see which survived the longest. I made 6 iterations of my bot, and using those bots I was able to make them compete with each other in order to filter out any features that was not needed in order to survive. And the main thing I added was attacking. So we can go and load my last iteration so I can explain it thoroughly. As you can see on my screen, we have Mujahid's code here. So this might look complex at first, but it's really simple. So here in our first region, we have a basic conditional set state that sets the state to gather only if the container exists or isn't destroyed. And if the container got destroyed, aka doesn't exist, then we pass down the state to another conditional set state, and this one actually decides whether to eat or gather based on my hunger value. You can notice this similar setup to AIA's bot, but we have another addition, which is this buffer. This was the fix to the issue I mentioned earlier, which was the jittering in the bool. This gave me 2 benefits. One of them is giving me a bigger time between eating and gathering. Another benefit was keeping the hunger high, So these two regions are the ones that control the eating and gathering based on the hunger. So that was all the code that controls the eating and gathering. Here we have the two biggest regions, which are the ones that control attacking. My goal was to make my bot only attack back. A problem that I noticed was that self was attacked. The bull that decides whether I was attacked or not stayed true for around 5 seconds, which is not great for my situation because I want to only attack back until I kill or until I get really low on health and I flee. When I keep it to 5 seconds, this makes it so that if I get attacked and I started attacking back and he died, I still attack for another like 3 or 2 seconds, meaning that I could target another player, thus starting another fight. So by using this distance to last attacker, I can use this distance and compare it to a set variable, which is a safe space, like a radius around my player. And using that distance, I can know if the player was killed or the player just ran away. And using this simple contraption here, and using this bool that I mentioned earlier, I can know if I got attacked and if I killed the player I was attacking or not. Using this, I was able to only attack who attacked me until he died and stop after I killed him, which guaranteed me not getting any aggression. And here we have a simple code that checks the distance between my container and the nearest player, and based on that distance and a simple radius that I set around it, and using the bool that tells me if the container was attacked or not, I can know if a player is attacking my container, and I can also pass that down with the attack until you kill and stop attacking after that. And now with these two bools, I have a is_attacking/attacked bool, which I can use to control these codes here, but I'll get to this later. Up here we have two regions. One of them is a protection against starvation and stamina loss, and here is just two buffers that I used for these two. This is just an emergency mechanism, so if my stamina drops really low or my hunger drops really low, I can just stop doing whatever I'm doing and run away. This is just a simple failsafe, and that gets passed down to these balls here, which are just sequential balls that decide whether I should attack or not. Up here we have two regions. One of them just makes me flee if my health is too low when attacking. This can be done using the passive state, which simply makes me flee away. And this is a variable that controls when to flee. And here I just debugged. And this all gets passed to a conditional set state. And down here we have this big region, which is basically if my hunger is less than 100% and I have only 20 seconds left and I'm not fighting, I can just eat. This is to guarantee me getting a higher rank, because the hunger is a value that's used in the ranking system. You can see that these two regions use the bool I talked about earlier. That's to know if I'm getting attacked or not, in order to flee or just eat based on this region. And here we have this simple stamina control. It also has a buffer here, and here I have the exact same system I have from before. It's just that if I get attacked, I'm gonna have to run even if my stamina is above 0.7, and I stop running at all times if my stamina is lower than 0.05. This guarantees I have a attack left, so if I was getting attacked, I can just attack back, which should save my life, basically. And here I just have the variables I use for my code. Here you can see that I only set them in the first second of the simulation using this counter here. And I have all of these conditional set floats that set the float based on the value I gave it. And here I have the fixed variables that never change, because these are used for setting the actual values that I need to use. These values are used for the buffer, and these values are what's getting passed into the buffer. To explain the buffer, I have this conditional set float for each value, and basically if my hunger in this situation drops below 0.5, I start eating until it reaches 100%. This is done by checking if the value is 0.5, and if the value is 0.5, I can start, my optimal hunger value, which is used here, is getting set to 100%. And when it reaches 100%, you can see that it's set to 0.5, meaning that it's like a switch, in other words. And this is my code. I have some extra stuff over here, like a switch that I never got to use, and a clock that I also never got to use thanks to blockheaded moronic idiot. And the other one is also made by a blockheaded moronic idiot. Here we have a debug zone that I used to check all the values, and that is simply my code. I hope I explained it well. After some extra iterations, I was able to land on a final code. This is the approximately same exact code. I just modified it a little bit more by adding some stuff here and some pixel art. We also have some better naming, and we have some better line work. And I just cleaned up some stuff here and there to make it easier to understand. I'll put the link for the code explanation in the description. You can go and check that out. And thank you for stopping by, and I hope you have a great day, and see you later. Bye.